Hi everyone, my name is Guanlin from the Analytics Lab, and my research title is AI as a creative collaborator in architecture, bridging data-driven design and human-centered creativity. Something about me, I graduated with an MPhil degree from UNSW, Built Environment, and I also got my Bachelor of Computational Design degree from here as well. I'm working as a research assistant in a human-to-machine collaboration project since February. And back to the topic. The AEC industry remains one of the lowest digitalization fields globally. This means we still face huge challenges in terms of efficiency, cost control, and quality of results. With the rapid development of AI, the AEC sector is engaged with AI adoption into its workflow. However, the integration is still limited. The complexity of architectural design demands more standardized and comprehensive integration strategies. On the other hand, AI integration will reshape the paradigm for the creative design process. AI has the potential to inspire human designers with unexpected outputs. Moreover, the communication threats from AI, like the large language model, is able to be a design collaborator. But to this day, the question of whether AI can truly enhance human innovation and efficiency remains controversial. Recent studies have shown that AI-assisted creative writing may actually reduce users' cognitive engagement and problem-solving efforts. When people become overly reliant on AI, they may stop engaging in independent thinking and more likely to stick with one single idea generated by AI throughout the whole process. Furthermore, experiments have found that software developers sometimes spend even more time completing their tasks when they use AI tools. In this sense, AI is a double-edged sword. Without the right strategies, instead of advancing the work, it can even hold the progress back. So this research contains 3 key domains which address 3 gaps. Most research or industry practice still take AI as an external automatic tools outside of the main workflow. Human-to-AI collaboration identifies the complementary roles of both human designers and AI. Use AI in the right way to avoid time load and extra risks is important. Secondly, most studies of creativity often prioritize novelty over or ignore functional performance at the early architectural design stage. Therefore, this research will consider not only the novelty, but also the usefulness of the design outcomes. Last one, as I mentioned before, AI integration is still limited in today's AEC field. It is fragmented and lacks satisfied standardized workflow strategies and guidelines. So in response to this research aims to test whether human-to-AI collaboration can enhance functional creativity and outcome for performance, and aims to identify the functional and factors that support or hinder the human-to-AI collaboration in architectural design. Instead of being just one person's idea, the design should grow through the collaboration with AI, through dialogue and interaction that spark new inspirations. For example, the large language model AI can propose design ideas by analyzing the interdisciplinary information, such as cultural context or historical backgrounds, which the designer might not know. To achieve these objectives, the study proposed to use 3 technical approaches. Model Context Protocol, which is MCP, will be used to embedding the large language model AI into a workspace, which is familiar to the architects, like Rhino and Revit. AI can interact with designers in real time, enhancing communication and user acceptance. Also, they'll be able to generate models directly into Rhino or Revit. A local database library with previous design examples will be developed to support AI's understanding about architectural design logic. Last one, it will use AG equipment to monitor the brain activity, therefore evaluating the creativity with more subjective data. This AG data will be aligned with user interaction logging data to get a comprehensive analysis of designers' behaviors and cognitive process. And also by using a transformer AI model, we can identify optimal decision-making pathways and optimal strategies and enhance the creative efficiency. So the core research method is protocol analysis conducted through a controlled design experiment. Although there's a gap between experimental environment to the real-world architectural design process, this combination is most suitable for a complex study of architectural designers' cognitive and decision-making process. The proposed experiment involves 30 participants with experience in architectural design using digital tools such as Rhino and Ribbon. The proposed methodology can be separated into 3 phases: preparation, which involves a systematic literature review, which I'm doing right now, and experiment and data analysis. The research used multiple data, including protocol transcripts, to record the design process and designer's thinking process. Brain signal data will help to find the highest peak of cognitive activity, which point is the most engagement with creativity. And user interaction logs will be collected to analyze the full workflow. Design outcomes will also be used to examine the functional creativity. We also run a survey which experts in academic and industry can evaluate the design in terms of both creativity and the usefulness and functions. Finally, I would like to highlight the implication of this research. On the academic side, it shifts AI from being viewed simply as tools to becoming into a true collaborator like your colleague. And by incorporating multimodal data such as AG, it contributes to improving the environment framework of creativity. On the practical side, it offers the AEC industry a possible integration pathway, demonstrating how AI can be effectively embedded into existing workflows to minimize the risks while enhancing both innovation and design quality. It will provide the industry with a clear guideline, like how to maintain creativity while ensuring functionality and feasibility in integrating AI into this field. And that's all. Thank you for listening. And yeah.
Thank you, Guanlin. Maybe as a little kind of side note, here's a poster, and the exhibit is somewhere around as well. So Chris and I conducted a studio at the beginning of this year in term 1 with the third year computational science students. So we looked into prompt engineering in combination with Rhino to generate geometry. It was a very interesting experience for us to trial that, and for the students as well. What we've done was a relatively simple exercise of scripting a node, a structural node, out of prompt engineering, and the challenges that the students had then in terms of describing the prompt, being very precise in their prompt, but also the complexities of the prompt or the large language model, understanding the syntax of Rhino as well there. So maybe there would be a few students to talk to, because we asked the students in a video presentation to give feedback on their experience of doing it in a conventional kind of way. In BNB 10-12, you've done as well, with the same kind of exercises, where they scripted normal and Grasshopper, the same kind of things, then versus the prompt engineering. And that totally, I think the students thought it was by far more easier to do it in Grasshopper only than a large language model. But again, it was the first time they exposed themselves to large language models in this kind of sense. But also it showed quite nicely that in order to prompt engineer and use it for coding, you have to be very, very precise in your commands. So you need to understand coding quite well as well. And we could unpack some challenges in the students' understanding of coding that they weren't really able to structure the coding in their brain before they explained what they want to do. So a lot of the kind of confusion was in the matter of fact that they didn't really know how to structure their code very well. So have a look here and have a chat to Chris and me as well if you're more interested about prompt engineering and computational design. But over to the audience for any questions. Yes, please.
Thank you for the presentation. A couple of related questions, just sort of coming on the tail of what Hank was saying there, around sort of the repeatability of generated outputs.
Yeah.
Very difficult to achieve from what I've seen, and so I suppose that's what we're trying to control for in some respects, is that, you know, level of repeatability so it can be trusted. Recently, tailing on to that, GitHub have just released something called spec-driven development, where it's moving away from kind of prompting into sort of specifications, and then having agents build out all of the computational aspects based on the specifications. So it's just a sort of comment on, you know, again, this incredibly changing domain.
Yeah. Thank you for letting me know. I definitely check it out.
Yes, Jen, just a second.
Contextual question. And what's your background? Are you from architecture or from coding or?
I'm from MPhil degree in built environment, still in University of New South Wales, and my another background is bachelor degree of computational design, still from there.
Thank you very much.
Okay.
Yes, please.
Thank you, Guanlin. Just a couple of comments. You have a beautiful challenge here with trying to deal with AI and human cognition. And you've got a great opportunity in the center to talk to people who actually study human cognition.
Thank you.
I highly suggest you talk to Lisa, Christian, maybe someone in psychology about how they measure these kind of things, including EEG measurement systems and approaches to help you get this. This is an important question, and it deserves a really sharp kind of investigation. So I would ask you to ground that.
Yeah.
I think the hint you were just given about AI progress is also a critical issue. There's some controls here that are really necessary, and that is like the humans you're testing, do they trust or not trust AI, or to what degree do they trust it?
Yeah, because there's acceptance issues in here, and so I was wondering to take a controlled experiment. You know, one group using external AI and one group using AI that embedded in the familiar space that might help with acceptance. But let's see what happens.
The AI specification is critical in my mind here because, for example, I'm in business. If I did a business study in June with using ChatGPT, I would have had one perspective, even if I were using deep research. But after mid-August, with GPT-5, I have a totally different view of what that would look like using ChatGPT 5 Pro. The progress those AIs are making also has a big influence on the human as well as its capability to do stuff. So you've got to look at that interaction very, very carefully. So good luck, but talk to some people in the center to help you there.
Thank you so much.
That's a great comment, George. Just a little add-on. Because everybody's busy, you know, if it's difficult to get a psychology professor or something, they might be able to give you one of their PhDs to work with who's in a similar area, and that's always a good way to go when you're looking, because the analytics on EEG are way over my head anyway. We've had PhDs involved in that, and you do want to get some experts involved.
Yes, good way. Thank you.
Other comments from above? Maybe one other element that just came to mind when I was seeing your presentation is the aspect of work and how work will change in the future. And yesterday morning I had a discussion with an insurance company that insures architects, and one of the lawyers there was very much interested in the idea of AI and the transition of work. So maybe there would be another kind of avenue to say, well, if you have an AI human collaboration, and you look into the creativity of that, how it enhances or hinders creativity, you also probably could extend it, whatever, in the role of how it hinders and enhances the work a human is doing, what relationship between you and the machine in terms of labor it would be.
Yes, and I think this can be span is not limited into creativity, but also in different cognitive and so on.
Good. You really can see it's early in the morning. Not everybody took their chance of having a coffee yet to have a lively conversation, but I think they will warm up during the day, one way or the other. So thank you very much for your presentation.
Thank you.